discussing ATM, asynchronous transfer mode, for your curriculum. So what is ATM? So everybody knows this is one fantastic data link layer protocol. Now what is data link layer? So as we know, we have different layers in OSI layer. So we are talking about this layer 2 data link layer. So whatever data we are sending from upper layer, so we have to encapsulate data, we have to add CRC, we have to add a header byte in its address field, and then we have to encode the data at the physical layer, and then we have to send the data through transmission line. ATM, asynchronous transfer mode, is very popular because it is less complicated than other technologies. Like we have HDLC, one encapsulation method at data link layer, where we are adding some CRC and some header byte, and it is a little bit complicated here. In HDLC, as I discussed, the size of a frame can vary from 56 byte to 1500 byte. But in case of ATM, here we have kept cell size as a fix, like 53 bytes only. So 53 bytes, why 53 bytes only? I will come on that later. But hold these 53 bytes again further divided into 5 bytes for header and 5 bytes and 48 bytes for payload. So why we are using ATM? So we can use ATM to carry all other information like video, voice. So I can show over here whatever information you have, like telephone lines are there, and or suppose some computer and some digital devices are there. So you can we can send all this information through a device, what we call as a ATM switch. First we have to convert this analog information to digital, and then we can put this information in ATM cell. And since the ATM also uses multiplexing, so we can send multiple information through this medium to destination device. So here we can use this ATM and data link layer protocol for sending voice, data, image, almost everything. It can also support your new technologies, like we can map our ATM cell in SDH frame also. Now what is SDH? Now I am not going to discuss anything about SDH currently, because SDH is a huge subject out there. But here we have some containers, and we can send this ATM cell through STM1 or STM4. So we can put this information through SDH also. Now every country, they may have their SDH network. So again, as I discussed, ATM can support voice, data, image. Also it can support new upcoming technology also. VPI and VCI, two important thing where I want to talk about. This is only introduction. I will be explaining all those detailing later. But as I said, in one ATM cell, 5 bytes are for header. Now these 5 bytes again further divided into multiple fields, like generic flow control, VPI and VCI, then header error check, cell loss priority. These are some different fields are there. But currently I am talking about two important, VPI and VCI. So VPI stand for virtual path identifier. Almost 8 bits are there. And also VCI virtual circuit identifier, and 16 bit can be there. So VCI virtual circuit identifier. So these two field gives us exact address, or through which circuit we have to send, and these two are designed in such a way that these two field will help to reduce complexity of that device. So this is again one advantages. Statistical multiplexing also there. Then what is this statistical multiplexing? Now let us go back to what is multiplexer is. So multiplexer is a device where we can put multiple signals through one similar link. So this is a combined output line where multiplexed output, and these devices can send their information. Okay, so this is a standard multiplexer. But what is statistical multiplexing? Suppose this device, suppose second device is not working, or a user is not sending any information, then what will happen? We are not using this second time slot. So sorry, 4. So we are not using these resources properly, we can say like that, because this device is not working, so we are not sending data during that period. So in a statistical multiplexing, if medium is free, then same device, like I have drawn over here, same device can send its information through that empty time slot. That it's where demand on bandwidth on demand, sorry. So bandwidth on demand is the main concept which we can use in a ATM. So that is why we have used this word ATM, asynchronous transfer mode, where A stand for asynchronous, and here we are using statistical multiplexing, means not synchronous in this way. So if we are somehow, as you know, different countries, they are located away from each other, and we are using some under submerged cable, like some under submerged cable. So if we can use this medium, or we can use this ATM for sending ATM frame with the help of statistical multiplexing, we can use this medium effectively. So why only 53 bytes? Why only 53 bytes? So 53 bytes are not exactly very large number, like, so there are, as you know, there are two standards. One side ANSI is there. ANSI is responsible for building standards for American continent, while at another side we have this ITUT for Europe and India. We generally we use this ITUT specification. Now whole world has been divided into two parts. Like at one side, some organizations they can use ANSI. At another side, the organizations or countries they use ITUT specification. And also Japanese and Chinese, these are the different countries, they may have their own specification. But as I said, ANSI they came with, we will be they said okay, the packet or cell should be 64 bytes. But ITUT, a European, since they were not having the echo cancellation technology, so they were expecting the standard should be came with 32 bytes. So as a result, ATM forum they have evolved with one different concept, where we are using only 48 bytes for a payload and 5 bytes for header. Okay, so if we are keeping higher bytes in a payload, this may create packetization delay. So suppose if a signal is moving through one link, and suppose if we want to switch, if the signal or packet is too large, then another signal has to wait for a longer time, so packetization delay can be there. So keeping packet or cell size smaller may avoid packetization delay. So ITUT was expecting that cell should be smaller, so that they actually they was not having the echo cancellation technology. Well, in American continent, every exchange and every equipment is equipped with echo cancellation technology. So now currently ATM forum arrived with 48 byte packet. Okay, up till now we have studied different parts of ATM. Like ATM can send any kind of data, like video, voice, and other things. Same way, it can support SDH mapping. So we can use new upcoming technologies with same ATM encapsulation, VPI, VCI also there, and by this method we are actually reducing some less complicated device we can use with this field. And statistical multiplexing is also there, so here we can use bandwidth on demand concept. In same way, we have discussed about why we are using only 53 bytes in a one STM cell. So let us start digging ATM cell. So here I am drawing one protocols track. So here we have this physical layer, and then we have data link layer. ATM, this is physical layer, and upper layer is called as a ATM layer, or here exactly encapsulation takes place. So this is our ATM layer. Same way, there is one more layer, another layer we generally call it as a ATM adaptation layer, AAL. Then again, AAL may have different AL type 1, AL type 2. So different applications can use different ATM adaptation layer. So I will explain all these things in upcoming slides. So in this way, physical layer again further divided into two parts, like PM, like physical medium, and again I can draw over here PM, and again transmission conversion, TC. I can rub this thing over here, and TC, transmission convergence. So just I can say like a PM again responsible for encoding which medium we are using. Like if we are using copper cable or if we are using fiber optic, then encoding task can then why we have to encode this data. Okay, let us discuss what is PM or physical medium. As I mentioned here, three layers are there: physical layer, ATM layer, and ATM adaptation layer. Physical layer further divided into two parts: physical medium and transmission convergence. Physical medium is responsible for encoding. So why we are using encoding? There are different types of encoding, like return to zero or non-return to zero, where we can find Manchester encoding, differential Manchester encoding, HDP3. Why we have to encode data or converting DC signal into DC signal? Because I can say, like, suppose two devices are there, okay, and these devices they want to communicate with each other, and if they are using the serial bus over here, how will they provide clocking pulse to each other? Because clocking pulse is an important factor where both devices they must be synchronous so that we can send data faster. Okay, so if we want to send some data, we have to send clocking pulse also. So here we use encoding. Now don't get confused between encoding and encryption. Encryption is for protecting data. Generally presentation layer takes care about this encryption thing, but here I am talking about encryption. Encoding is like